Okay, how to use an EPOCH set. Let's start with an EPOCH 4B. Now they're all very similar, that's the good news. On this one we have a set of F1, F2, F3, F4 and F5 keys, which are quick functions. But first of all, amplitude. Click on gain and then use the up cursor arrow or down to reduce the amplitude. For range, before we move off range, on the gain, it gives you quick F1 to F5 keys, 60 dB, 10 dB, 30 dB, 40 dB. On the range, we can then click left or right to change the range, or click on the quick keys button, for example F4 for 100, F2, F5 for 200. Zero offset set, cursor keys to move left or right. Click on range again, I'll make the range 100. Gate, click on gate 1. We've got the F1 to F5 options. F1, gate start, we can move the gate start position. F2, width. F3, level. And F5 is a nice little trick, it'll set the echo within the gate to 80% full screen height. I'll show you again. Peak memory will record the highest echo. I'll reduce the amplitude there. So you can see it's recording the echo position here. A P is displayed here, letter P, to show that peak memory is on. Display will change the display. Now for correct calibration, we have to set the angle. In this case, this is a 60. We can go on the F4 key to quickly set 60. We have to set the velocity. In this case, this is shear wave. So it is about 3,240 meters per second. If we're on a zero probe, which is a compression wave, we'd have to set that to about 5,800 meters per second. I'll put it back on the 60, which is shear wave. So I'll put it on about 3,200 meters per second. Right, so to calibrate, let's put it on the V2 block. Turn it around to face the 25mm radius. Now, I'm going to click the range, move that slightly that way, and then increase the, actually I'm going to increase the range a bit, and then zero offset, move it back. And when you're on a graticule line, the front edge of the echo becomes dotted. So that's not a bad calibration. Turn the probe around, should be about the center, that's correct. Now you'll notice the readings we're getting. Let's just check it on the root. Increase the amplitude. Now this is telling us the depth vertical down is 20.86 millimeters. The standoff distance from where it's detecting this echo, which is the root, to the emission point in this distance here is 36.16, and the actual beam path the distance the sound has travelled is 40.49. That's the distance down here. Now, what I'm going to do now is take it back to the calibration block, which is the V2. I'm going to look at the readings here. The distance here says 24.69. It should be 25. To get it exactly right, I'm going to change the velocity. Now I'm changing the velocity, and these readings are changing. This distance should be 25 millimeters exactly. There. So now we'll get an exact distance to our route, which is now just about coming up for about 40 millimeters, a bit short. 40 millimeters, 41. We're just going to the other side of the route. Standoff is 36. Depth is 22, which seems right because this is 20 mil wall thickness. The extra route about 21.61 deep. Now to calibrate for the 0, again we'd have to change the velocity. Click on velocity. The velocity of compression wave is approximately 5,800 meters per second in steel, carbon steel. And move the gate position this way to catch the first echo. Change the angle to 0. And now I'll put it on the V1 block. And I'll open up the range. To get 2 echoes. I just clicked on the F3 to get 50 millimeters, but it's not accurate yet. I'm going to use the cursor keys to adjust the range and the X offset. Right, that's about right. Now 1 echo at 25, second echo representing 50. You can see the reading here says 24.7, so we'll correct by adjusting our velocity. Click on velocity, change the velocity until this reading says 25. Wrong way. Increase the reading of the velocity in here until this reading says depth 25. Right, that says 25. We can click the V1. We can confirm the thickness of this metal is 20 millimeters.